Is the share working all right?
Yep.
Okay. All right, so today I'm going to talk about SQRL, which stands for Secure QR Code Login, or more recently, I guess it's Secure Quick Reliable Login. They wanted to put a little less emphasis on the QR codes. This is the brainchild of Steve Gibson. He runs a site called grc.com that you may have run into. He has a lot of really nice freeware out there, and also one paid product, SpinRite, which is a disk maintenance tool. Shields Up's a really nice thing that the website provides. It'll scan ports on your machine and let you know what you have open. He has a newer one called Never 10 that stops Windows from nagging you about upgrading to Windows 10. So if you don't have that, that might come in handy. But he's also the host of the Security Now podcast, which is a weekly podcast about computer security. And it is a really excellent podcast. I would recommend that to anyone who is interested in the topic. And because of that, he's done a lot of thinking about passwords. And he came up with this SQRL as a solution to that problem. So passwords are kind of terrible. The current state of passwords is not really good. If you have memorable passwords, then they're easily guessable. And you can't really rely on the password database on your favorite website staying secure. They seem to always be escaping. And memorable passwords tend to be reused across sites, right? So if you have passwords that you actually know, you'll tend to reuse them. And then when one of those databases gets compromised, you will have people getting into other accounts that belong to you. This actually happened, I think, in the last couple of weeks. LinkedIn had a gigantic password leak, and Twitter and GoToMyPC and maybe some other sites had to reset a bunch of accounts because people had reused the same passwords across sites. So if you really want security with passwords, you need them to be random, and you need them to be different for every account. And that's terrible because you can't remember them then, right? That makes it a challenge. For technical users, something like LastPass is a pretty good solution, right? We can store our passwords in a vault and let the computer do the work of remembering them. But for non-technical users, that's a little more challenging. There are some things that don't go smoothly with a tool like that. When markup changes on a page, sometimes the tool can't figure out how to put the password in. Sometimes a site redirects you to a different subdomain, and the tool doesn't recognize the domain, and then you have to go hunting and try to figure out which password stored in your vault is actually for this site. So that helps some, but it's still not a great solution. SQRL gets rid of passwords entirely. It uses a totally different approach. So first I'll tell you what it looks like from the user's point of view, and then we'll dig into some of the details of how it works. So the idea with SQRL is you create an identity, and you can either run the SQRL client app on a mobile device, or you could run it as a browser plugin. And then when you go to a website that supports SQRL Login, you will see a QR code, something like this, next to the login form. And to log in, you just snap that QR code with your phone, and it will say, do you want to log into paypal.com? You say yes, and then you click the login button, and you're into the site. So you never enter a password. You just scan the QR code, and then you are in. So before I talk about how this works, I'm going to review a few little basic things that some of you may have forgotten. Some of the pieces that SQRL uses. So it uses cryptographic hash functions, which take any data input and convert them to a random looking digest. So you can see here, if we put in the input Fox into this function, we get out some garbage. And if we put in a different sentence, we get different garbage. If a hash function is secure, that means a few things. One is that small changes in input will lead to large, unpredictable changes in the output. You can see here that changing one character in the input sentence changes almost every part of the output. It's completely unrelated to the first digest. It also needs to be infeasible to reverse, so you should not be able to go from the digest back to the input data. And you also need to not be able to find collisions. So it's really important that you cannot go find other input that will give you the same output. The main thing that SQRL uses this for is the fact that it's irreversible. When you have hashed something, you get random looking output, and you cannot go backward to the input data. Another piece of SQRL uses public key crypto. With public key cryptography, we generate a key pair with a private and a public key. And there are two ways that's generally used. One is to send data from one party to another. So if you have someone's public key, you can encrypt it, the message that you want to send with that public key, and then send off the message, and only someone with the matching private key can decrypt it. So obviously you would keep your private key private and put the public one out there. You can also use a key pair like this to sign messages and prove that they are from you. So you can add a signature to a message with your private key, and then anyone with your public key can use that to confirm that the person who signed the message has the matching private key. So they, assuming it hasn't gotten out of your control, they know that you really sent that message. The public key crypto that's used in SQRL is the 25519 elliptic curve, which is a newer type of crypto. This prominent security researcher, Dan Bernstein, has done a lot of research on that curve, and it is believed to be pretty secure. The really interesting thing and the essential property of that curve for SQRL is that you can use any 256-bit value as a private key. So with some types of public key crypto, you need to generate 2 large prime numbers or something like that. And so there are constraints on what data can be used as a private key. With this curve, you can take any 256-bit value and turn it into a private key. You do have to twiddle a few bits. I think you turn off the 2 lowest bits and turn on bit 31 or something like that. So you lose a little bit of the entropy, but if you're starting with 256 bits, that's really not a concern. When we have these key pairs, we can also do something called Diffie-Hellman Key Exchange. So this is often done when 2 parties want to communicate with each other and they each have a key pair. It turns out it's really pretty computationally expensive to use public key cryptography. So you don't really want to use that for your whole conversation. You could do that. If we have Alice and Bob and they want to talk to each other, then they could exchange public keys, and Alice could encrypt every message she sends with Bob's public key, and he would decrypt it with his private key, and then he would encrypt messages back with her public key. And that would work, but it would just be very slow, relatively slow. So what's actually done in practice is the public key crypto is used to establish another secret that Alice and Bob share, and then they use that secret to key some other encryption algorithm that's much more efficient. So they can do that by exchanging their public keys and then combining the other user's public key with their own private key. So if Alice combines Bob's public key with her private key, she will arrive at this number. And when Bob does the reverse, he arrives at the same number. So then they can use that shared secret to key another algorithm. This is also kind of interesting because it's secure against eavesdropping. If someone is watching them exchange the public keys, that doesn't matter. That can be done in the open. They still arrive at the shared secret, and the eavesdropper has no way of figuring out that shared secret. All right, so with those pieces in place, we can talk about how SQRL gets the job done. So when you create an identity with SQRL, the idea is that this will be your identity for a long time. This is going to be the identity you use to log into every site, and it hopefully will never have to change. As long as it's never compromised, you should not have to change it. So the first step is generating this identity, which is a random 512-bit number. And then you print a QR code for safekeeping. So the client will actually go through some extensive encryption. It does many rounds of scrypt so that it's hard to brute force this in case someone got your backup QR code and decided to try to crack it. You enter a password. The identity is encrypted with that password and printed out, and then you put that somewhere safe. You also use that password to protect the identity within the app, so the identity is encrypted using that password and then stored in, say, your mobile phone. The way that SQRL actually works is that when you go to a site, it generates a unique key pair for that site. So it takes the domain of the site, in this case example.com, and it takes your identity master key, which is basically a large random number, and it hashes those 2 pieces of data together. That gives a random output that's the correct size to be a private key, and it then generates the matching public key from that private key and uses this key pair as its authentication for the site. So when you set up an account with the site, you give the site the public key that's generated from this operation. All right, so you've taken your master key, matched it together with the domain name, got some random output, generated a key pair. You give the public key to the site, and then whenever you come back to the site will send you a challenge. So the QR code that we saw on the login form earlier is really representing a URL that looks something like this. And this last part here is really just a giant random number. So the SQRL client will take that large random number, it will sign it using its private key, and it will send a signed challenge off to the site. The site can then check that signature against the public key that it has in its database, and if they match, then it knows that whoever signed it has the private key and is presumably you. So that's how authentication works. Basically, you're proving that you have this private key. Now, there are a couple of nice things about this. One is that the server has no secrets. So the server saves your public key and doesn't have anything that could be revealed in a database breach that's sensitive, right? If that public key gets out, it really doesn't matter very much. Accounts also cannot be connected across sites. So if you use SQRL to log into a bunch of different sites, they can't get together and compare their databases and figure out, that you're the same person on different sites. Of course, most sites are going to have you enter your email address, so you probably could be connected. But as long as you don't give them other personal information, they won't be able to connect you. This is also because the keys that are generated for every site are different, right? So each site gets hashed with your identity to generate a unique key pair for just that site. This is also nice for sites where you might not want an account. If somebody wants to set up a sort of lightweight process, maybe on a forum where they will allow you to post without you really creating an account, but they don't want you to be able to impersonate other people. This is a pretty good fit for that. There's no keyboard interaction here, so if you're on a public computer, it doesn't matter. If there's malware in there that's trying to log keystrokes or something, that just won't be a factor. It uses out-of-band communication, right? We really have two separate lines of communication, your web browser to the site, and then the SQRL client, which maybe is on your phone, to the site as well. So if somebody wants to get up to trouble by intercepting connections or trying to mess with data, then the job will be tougher just because of that. This is a trust no one solution. No one else has your data. Nobody has access to your data. That also means you have the responsibility for keeping track of, say, your password. If you lose the password that encrypts your master identity, you are completely out of luck. All of the crypto that's used in SQRL is free and has no patents or other intellectual property issues, so that should not be a hurdle for adoption. And then finally, there's a feature called identity lock that lets you regain control of your identity if you lose control of it. I'll talk about that in a minute. So what kind of attacks are available on SQRL? These are just a few. There's actually a more extensive list on the site, but these were the most fleshed out at the time I was writing this. Attacking the public key itself is one possible attack. If you got a hold of the public key from, say, PayPal's database and you wanted to log in and impersonate that user, you could try to do that by finding the matching private key. The elliptic curve crypto that is being used here appears to take 2 to the 140th power work to break. And so that's quite a bit of work. That's well beyond anything that anyone has ever cracked. And even if you did do that, it would only let you log into that one account, right? Remember that the hashing that takes us from the master identity key to the key pair that we use for the site is a one-way operation. So even if someone did figure out the public and private key that's in use for, say, PayPal.com, they wouldn't be able to work backward from that to the identity key. So they wouldn't be able to get into any of your other accounts. You could try to brute force the password. So if an attacker had gotten a hold of the encrypted SQRL identity, which is stored in a couple of places. One is it gets printed out when you first create your identity for safekeeping. The other is it is encrypted using your password and stored on whatever device has the SQRL client. So we could try to brute force the password, just guess passwords and try to decrypt that identity. Of course, if you use a terrible password, this will be easy. But assuming you've used a decent one, it should be pretty hard to break. Ascrypt is used to encrypt it, and it's used in a memory hard mode where it uses 16 megabytes of RAM, and it's a sequential process. So this is not the kind of thing that you can farm out to a bunch of GPUs and have them work on it as you would if you were, say, I don't know, creating rainbow tables or something like that. You pretty much need a real processor to work on this problem. And it's a sequential function also, so it's not easy to break this type of encryption up into parallelizable parts and then assign them to multiple CPUs. So that seems to be fairly difficult. Another possible attack would be for an evil website to try to get control of your account. If, say, evil.com wanted to log in as you on PayPal and steal all your money, they could present a login form on their site and then go to PayPal and get the QR code from the login form there and display it on their own login page. So you would snap that QR code with your app, and this is why the app actually confirms the login before sending it off. So what would actually happen in this situation is you would snap the QR code, and the app would say, confirm that you want to log into paypal.com. And you would hopefully notice that you were not trying to log into PayPal, so you would say no. One attack that is viable against Squirrel is phishing. So if we have a site that looks enough like paypal.com to fool the user, and they steal the QR code from the real paypal.com, then you will probably log in, right? So you'll scan the QR code, you'll think you're logging into PayPal, and so you'll say yes on the app when it asks you, and then that site will be logged in as you and able to do things on your behalf. There are a couple of things that can be done to mitigate this somewhat. If you want to, you can tell the server that you're running in a certain mode where the request for the QR code and the signed request should come from the same IP address. So if you were running, say, a browser plugin on your computer, and the browser is requesting the QR code and then sending the request, those would come from the same IP address, and the server could confirm that before letting you log in. Another thing that can be done there is if you're using a mobile device, but you're on, say, your home wireless network. Again, the request for the QR code and the signed request will come from the same address. So that's something you could turn on if you wanted to, and it's available as an option. But the main thing to do here is don't click on suspicious links. All right, so I want to talk about identity lock, which is, I think, the coolest feature of Squirrel. It's a little bit complicated, but I'll do my best here. So the idea of identity lock is that we could lose control of our identity, right? We have this identity, and the intent is that you would use it for, your whole life. It would last forever. So losing it would be a big deal. Someone gets into your phone, maybe you install a malicious app, and it steals the unlocked master identity key, right? It's been unlocked decrypted in RAM, and this exploit is used to go steal that image. So the attacker now has access to all of your sites. They can log in as you anywhere they like. So what can we do in this situation? Well, there are a couple of things we can do. One is that we can disable any accounts that we want using the Squirrel client app. All right, so that's built into the protocol. If you realize that your identity's been compromised, you could quickly go to the sites that you care about, say your bank and your email and a few other important places, and you could lock those accounts. And there's no way to unlock those accounts with the app in its normal mode. What we would like to be able to do, though, is go to a site and say, my identity has been compromised, and I want you to update it to this new identity. Excuse me. What happened? All right. Chrome. Are you guys still seeing this?
Yep. Yes.
Back to a slide now?
Back to slide.
Okay. All right. So where was I? Yeah. So what we'd like to be able to do is tell the site that our identity has been compromised and we want to update it. But of course, if the client app in the normal mode can do that, then the attacker who stole our data from our client app will also be able to do that. So we need to do something a little bit more clever. So the challenge is we're going to need some kind of extra information that the client app doesn't normally have to be able to update the identity. But we have to provide something to the server when we create the account with that server so that we can prove our identity later on. All right, we would still like it to not link our identity across sites, so we want it to be unique for each site that we set up an account with. And the system that generates this piece of data must not be able to prove the identity. So the client in its normal mode has to be able to generate some piece of data that we can use later to prove our identity, but we can't use it right now. And that seems pretty counterintuitive and maybe impossible, but it turns out it can be done. So this is actually how more of the Squirrel system works. I'm not going to get into most of the details here, but so far we've only really been talking about the identity master key. it turns out there's another piece that's important for this identity lock feature. There is a key called the identity unlock key that's generated once when you first create your identity. It's only ever stored in RAM, never stored in the client, and it's part of the printed out rescue information that you get when you first set up your identity. So basically, to get this back, you need to enter the system supplied rescue code to unlock it. This key is basically a random number that we're going to treat as a private key, and we make a public key from it. So we have a key pair here. The identity unlock and lock keys are a private and public key pair. The identity lock key is stored in the client and used regularly. The fact that we have this offline identity unlock key is the key to this feature. So what we're going to do is generate a random key pair for a site that we are setting up an account with. So we get this public and private key that are called the server unlock and random lock keys. And we also have our identity lock and unlock keys, which are always, those are part of our identity. They don't change per site. But the unlock key is in red here because it's not available in the client normally. And when we set up an identity with our site, we can create a shared secret by using the public identity lock key and the private random lock key. Now, normally, Diffie-Hellman Key Exchange is used to communicate between two different users, but here it's actually being used in a really clever way. It's being used to communicate across time. So we want to be able to generate a shared secret now, and then we want to be able to generate the same shared secret later using different keys. So when we first start establishing our account, we have this random lock key that we just generated. We have our identity lock key. We combine those to create the shared secret. Then we throw away the random lock key. So after we've stored this information with the server, we throw away the random lock key, and now there's no way for the client to recalculate that shared secret. It could do it if it had the random lock key the way it did it the first time. It could do it with the server unlock key if we had the identity unlock key online, but that is not online unless we're in the rescue mode, if we've entered our rescue code. So that's the key to this. Basically, when we're establishing an account, we can generate a random key pair, create a shared secret, and then we give the server some information about the shared secret. We give it the server unlock key, and then we use the shared secret to generate another key pair, and we give the server the public key from that key pair. And then when we come back later, if someone's stolen our identity, they won't be able to regenerate that shared secret, and they can't update our identity. But if we've entered the rescue code, which lets us load this identity unlock key into the app, we can ask the server for the server unlock key, combine it with this identity unlock key, and get back the same shared secret that we had earlier. And then we can use that to prove that we really are us, that we are not the attacker who stole the identity. So we can derive the shared secret once when we create the account. We throw away a key that keeps us from being able to generate it again. And then in rescue mode, we can regenerate it by loading the unlock key into the client app. So the shared secret is used just to sign a challenge. Basically, we use this to create a key pair. The public side of that key pair is given to the server when we're setting up our account. And then later, if we come back and want to unlock our identity and update it, we reproduce this shared secret, reproduce this key pair, and then the server will send us a challenge. We sign it with this private signing key and send it back to the server. And if the server can verify that that matches the key we gave it originally, then we can update our identity to a new identity. All right, so where is Squirrel right now? Well, it's actually just about finalized. The spec is being finalized in the next week or so. There are already clients built for all platforms. There are a bunch of mobile platforms available. Unix and Windows platforms are supported. There are server plugins available that make it pretty easy to add this to a web application. There are .NET plugins for Drupal, Rails, and WordPress. The APIs for these server plugins look really nice. It looks like you basically have to add 3 columns to your database for your users. You have the public key, that's just basically the identity key. Then you have the server unlock key and the verify unlock key for the identity lock feature. So you pretty much store 3 public keys, and that's it per user. And then in the API for these server plugins, you pretty much just call a method that says, is this person who they say they are? And it says yes or no. So it looks pretty slick. There's more info on grc.com. There's actually quite an extensive set of pages on SQRL with much more detail than I'm going into here. So I think this looks pretty cool. It seems like it could be a pretty good authentication solution for the less technical user, and I'm hoping it takes off. Any questions?
Yeah, although go ahead and leave presenter view so we can all see each other's faces.
All right.
So it seems to me like this technology could allow us to not have usernames either. Like you could
Yes.
just this and not have your email address associated with everything in the world. Is that right?
That is right. You don't need a username. You just have this public key. So as long as the server's happy with just having the public key as your identity, that's really all it needs.
And on the workflow of using this, it sounds like I'm a little fuzzy on actually using my phone to log into a site. So is that like showing a QR code on my phone that I show to a webcam? Or
No, you would scan the QR code on your phone, and then the SQRL client on your phone would make a separate web request to the server. And so the server gets this request over a side channel that basically says, the person you gave this challenge to is logging in, and here's the signed challenge. So the server's giving a unique challenge to each time that login page is loaded. The QR code changes.
So my web browser goes to a login, I get a challenge. I basically take a picture of that with my phone. My phone software connects to the internet, responds to the challenge, and then my web browser receives confirmation.
Right. Yeah, so either you click the login button without filling out the form and it just lets you in, or if the web developer is a little more slick, it just refreshes on its own as soon as you've sent that signed request.
Predictions on timeline to mass adoption or failure?
I have no idea. I hope it takes off, but you never know. I think it could be pretty cool. I think over the next year or so, it does pretty well. I think it starts to take off. Steve Gibson was talking about this. He's been working on this for a year or two now, and he started talking about it on the podcast quite a while ago. And he was at some kind of tech conference, and I think it was maybe around identity. And there was a guy giving a big presentation about this other alternative way of doing this kind of thing. And at the end of that talk, he went and talked to him after it and started telling him about how SQRL works. And the guy basically said, yeah, your thing is just better. This should win. And started promoting it, I guess. So at least a couple other people think it looks pretty good.
Do you think people will tattoo their one true identity as a QR code on their bodies?
That'll be their backup. Just don't forget that password.
Then we enter a dark dystopian sci-fi future. Any other questions for Tim?
So real quick, if you can hear me. Sounds cool. I love the idea of public keys being the thing I give out because I don't care about those. As with anything this massive, it seems like the transition from the existing state of we use passwords everywhere to this will not happen smoothly. It's a full replacement. And that seems like the biggest hurdle. Right now, if you use a password manager, you can still operate with regular sites where you can use 123 as your password because you're dumb, or a 16-character random hash that you store in a password safe. So it's cross-compatible.
Yeah, that's true. You can actually do this side by side pretty easily from the web application point of view. So you can just have a column for the hashed password like you do now in your database, and you can have the extra columns for the SQRL identity.
I guess that's part of what I mean, is that from my point of view as a consumer, I don't care if some dinky little website has SQRL or has old passwords because I choose how strong my password is. if I have to wait for every server to go upgrade, if I want to have secure passwords, that will take time. It's just a full replacement. Rather, I mean, yeah, you can do it side by side, but it's still server changes as opposed to.
Yeah, that's right. I mean, it's server adoption that really matters, right? So, you can have your Squirrel browser plugin and your LastPass plugin, and hope that over time you start using the Squirrel one more and more.
Cool. Yeah, that would be my adoption concern if I were deciding to bet on this one way or the other.
Yeah.
Sweet. Unless there's other questions. Okay. Well, thanks. Thank you, Tim, for presenting. Thank you, everyone, for attending. And join us next week for the next talk.